Hello students, I hope that you are good, well and fine. In today's session, we will be starting a new chapter 7, integrals. Okay, inverse process of differentiation. We will be mainly seeing in today's session about this inverse process of differentiation, which is our integrals. Okay, so in today's session, we will be seeing integration or anti-differentiation, constant terms. We will be seeing what do we mean by that. Okay, and we will be seeing uh, rule theorem. Okay, we will be seeing some remarks also, this symbol, this notation, some standard integrations, some properties, this rule and some examples and some remarks. We will be seeing all of these. So let's just quickly see. So anti differentiation is just another name for integration, as you can make assumption from this name. As inverse process of differentiation we are calling integrals. Okay, so integrals is just nothing but the inverse process. So you all know differentiation of sin x is cos x. This differentiation is just nothing but x square, and this differentiation just nothing but ex. Okay, clear? Okay, now this differentiation also gives you cos x. This differentiation also gives you the same thing, x square, and this differentiation also gives you the same output as you just saw in the previous slide. So this what it is giving to us. So it is saying that differentiation of two different things can be same, as you can see. So how this affects our answer in integrals, you will see. So this means, what more generally what we are trying to say is that if you have capital Fx plus some constant, then its differentiation will be Fx, where Fx is what? Differentiation of this capital F function. Okay, as you can see. Okay, clear? Okay, I hope it is clear to you. Okay, this is what we are saying here. Now what? Now the remark is the function with same derivative differs by a constant. To show that, let g, h be two function having the same derivative on an interval I. Consider f is equals to g minus h, defined by fx is equals to gx minus hx. For every x belongs to the interval, df by dx will be f prime, which is means g dash minus h dash. Prime means the derivative with respect to x. So f prime x is equals to g prime x minus h prime x for every x belongs to I, or f prime x is equals to 0 for every x by the hypothesis. Why? Because their difference is some constant number. Okay, function with same derivative differ by a constant number, we are saying. Okay, clear? Okay. Now this means what? That the rate of change of f with respect to x is 0 on I, and hence f is constant. Clear? I hope it is clear to you. Okay, let us move next. Now this notation, we introduce a new symbol, namely this integration. This symbol is what? Your integration symbol. Integration of fx with respect to dx, okay, which represent the entire class of antiderivatives. Read as the indefinite integrals of f with respect to x. Now symbolically we write integration fx dx. This integration is indefinite integral. You will later on see the definite integrals. Okay, for now, okay, for now this is your indefinite integral. You have to know this thing. Okay, now this will be what? Integration of fx dx will be just capital of fx plus c. This means what is your capital Fx? Capital Fx is just nothing but that this thing, f prime x is your small fx. This is what it is written over here. Okay, clear? Okay, for example, you just saw that differentiation of what? Sin x, differentiation of sin x gives you what? Cos x. So what it the inverse process? The inverse process will be integration of cos x. Integration of cos x dx will be what? What is your output? Sin x. But sin x, and here you always have to plus some constant number. As you all know that this gives you the cos x, also this thing also gives you the same output. That's why. Okay, Clear? This is your family of answers or family of curves for this. Okay, I hope it is clear to you. Okay. Okay, so let us move next. Now, some standard integration you must know. The differentiation of this x power n plus 1 divided by n plus 1 will be what? This thing. Okay, clear? Okay, this means the integration of this, as you can see, integration of x power n dx will be x power n plus 1 divided by n plus 1 plus c. You always, after integration, the indefinite integration, you always add this constant, some constant c, k, whatever you want, whatever you name it. Okay, so but you must add some constant. Clear? Okay, now derivative of sin x is cos x. This means integration of cos x dx will be sin x plus cos x. Now derivative of x will be 1 and derivative of 1 will be x plus c. As you can see, derivative of minus cos x is equals to sin x. This means integration of sin x will be minus of cos x plus c. Derivative of tan x is equals to sec square x. This means integration of sec square x will be tan x plus c. Derivative of minus cot x is equals to cosec square x. This means cosec square x is equals to integration will be minus cot x plus c. Okay, you must know them. Okay, otherwise you will fall behind. Okay, let us move next. Now some more. So sec x derivative is sec x tan x. Their integration will be integration of sec x tan x will be sec x plus c. Derivative of minus cosec x is equals to cosec x cot x. Now integration of this, as you can see, integration of this is minus of cosec plus c. Derivative of sin inverse x is equals to 1 by root 1 minus x square. Now integration of dx by root 1 minus x square is equals to sin inverse x plus c. Derivative of minus cos inverse x is equals to 1 by root 1 minus x square. This means derivative of root of 1, sorry, integration of root of 1 by root of 1 minus x square is equals to minus of cos inverse x plus c. Now derivative of tan inverse x is equals to 1 by 1 plus x square, but integration of 1 by 1 plus x square will be tan inverse x plus c. Okay, I hope it is clear to you. You must know them. Please do memorize them. Okay, these are basic things for this chapter you must know. Okay, let us move next. Now more forms. Derivative of e power x is the e power x. The integration of e power x is the e power x plus some constant c. Now derivative of log of mod x will be 1 by x. The integration of 1 by x is log of mod x plus c. Derivative of a power x divided by log x is equals to ax. The integration of ax will be what? This thing, a power x divided by log a plus some constant c. Okay, I hope it is clear to you. Okay, clear? Okay, let us move next. So you must know these basic forms for derivatives and anti-derivatives or integrals. Okay, let us move next. Now we will be seeing some properties of indefinite properties which will be helping us throughout this chapter. Okay, let us see those properties. So first property, what? That derivative of integral of fx dx will be just fx. Okay, so this means process of differentiation and integration are inverses of each other in the sense of the following rule. Okay, as you know, this is equals to this thing. So what this gives me is that integral of f dash x dx is equals to fx plus c. C is where c we are taking as arbitrary constant. So what it is saying is that, let me just give you an example so that you have clear idea what is happening. So d by dx integration of cos x. Okay, integration of cos x dx. So this is just same cos x. Simple. You know the integration of cos x. So just find it step by step. So you can if you are seeing this, okay, then you can directly jump whatever written inside, you can put it equals to that thing. Okay, you do not need to do this first and then the derivative. Okay, this will be your what, the extra steps, as you already have the result. Now if you go through a step by step, then you will have derivative of the integration for this will be sin x. Okay, sin x plus some constant. Okay, always add some constant in integration, indefinite integration. Now derivative, what you will have, cos x plus 0, this means just cos x. As you can see, this is what written, so we just skip this part. Okay, okay, so result says this thing. You can directly skip this part in order to find this. Okay, clear? Let us move next. Now same family curve means two indefinite integrals with the same derivative leads to the same family of curves, and so they are equivalent. Okay, in this sense they are equivalent. Okay, as you just saw, what differentiation of cos x, sorry, sin x, differentiation of sin x gives you cos x, and this is the same answer for differentiation of sin x plus 1 by 2. Yes, you will get the same answer. So in this sense they will have the same family of curves. Okay, they will have the same family of curve. What it means is integration of sin x is equals to what, integration of integration of cos x is same as sin x plus some constant c. C could be anything now, constant 1, 2, 1 by 2.5 or pi, anything, any real number. Okay, I hope it is clear to you. Okay, let us move next. Now this thing, this property is saying, then if you have to find, if you are having two functions and those functions are getting what, sum, as you can see fx plus gx, and you have to find the integration, then you can either find the integration after you sum them and then do your corresponding thing, respective thing, or another thing will be you can separate your integration like this form. Okay, so what it says is that if you are having like this, x plus 3 minus 4x, okay, sorry, minus x plus 3 plus 4x dx. If this is happening, either you can simplify, or if you are not able to simplify your thing, so don't worry, you can. Okay, so one way is that you can simplify. You will have 3x plus 3. Yes, 3x plus 3. As you can see, 3x plus 3 dx. Now your answer will be what? Now the, after what differentiation you will get this? You will get what? So what differentiation you must do? 3x square by 2 plus 3x. Differentiation of this, if you do the differentiation of this with respect to x, what you will get? You will get 3x plus 3. So your answer will be 3 by 2 x square plus 3x. This will be your answer, plus some constant, always adds plus some constant. One way is that. The another way is that you can separate your things like what? So it will be 3x dx plus integration of 3 dx. This thing, this will be what? The integration will be just what? Now this will be what? 3x square by 2 plus some constant, plus this will be 3x plus some constant, another, this is a constant for this term and this constant for this term. Now this constant plus this constant will become some another constant, I will be saying as c3 or just c. Okay, so like this. Okay, so you are getting the same answer. Okay, one might also give you the answer in this form, 3x square plus 6x plus c. So don't confuse. This 2 is in now in this for. Okay, clear? As c is a constant, so 2 merged with this c, giving me another constant, which is this time also I'm saying it is c. Okay, I hope it is clear to you. Okay, let us move next. Now if k is any constant, then k multiply fx dx integration will be, k can be taken out. As you can see, k can be easily taken out, so k multiply with the integration of this. So as we just saw, if you are given with this thing 3 multiply x dx, then its integration can be easily find. You can take constant term out. Now you know easily that what differentiation it is. Okay, so this will be x square by 2, just this. So you can get 3x square by 2. Okay, I hope that you are getting the idea what these results are trying to say. Okay, let us move next. Now let's see some examples to get better idea what is happening now. So for this we have to find the what antiderivative. So this means integration of cos x dx, cos of 2x dx. Now by inspection we have to do, so we have to know the differentiation of what function gives me what cos 2x. Yes, so one thing is that very clear, that sine of 2x gives me this, but sine of 2x gives me 2 of sine x, sorry, 2 of cos, this thing will give me this. So this means I have to divide it by 2. So by using normal thinking, you can say that this will be sine 2x by 2 plus some constant. Always adds some constant. Okay, clear? I hope it is clear to you. Okay, so you will have, if you differentiate it, what you will get, this 2 will be cancelled and it will become cos 2x. Now what about this? As you can see, so what function you must write such that their differentiation will be this thing. So differentiation will be this thing. This means x cube, if you differentiate it, what you will get, differentiate it, you will get 3x square. Okay, so this will be x cube. Now what about this? This will be x power 4. Okay, now plus some constant, you will get this. Okay, and directly you know that 1 by x integration is just nothing but log x, log of mod x. Yes, log of mod x plus some constant. As you know, the derivative for log of mod x will be 1 by x. Okay, clear? I hope that these examples are clear to you, and how we got to the solution is also clear to you by just method of inspection we did. Okay, let me just move. Now more examples. Let's see some more examples quickly. So first of all, simplify this term. So it will be x minus x power minus 2. Yes, x minus x power minus 2. This can be broken down into two parts. Integration of x minus integration of x minus. So this will be what, x square by 2. Yes, and this will be what, your plus 1 by x. As you can see, if you differentiate this, what you will get as x, if you differentiate it, what you will get, minus of 1 by x square. Okay, now plus add some c, you will get this as your answer. Now for this, and also remember that integration of x power n will always gives you the output as x power n plus 1 divided by n plus 1. This thing, as you can see also, x 1 plus 1 divided by 1 plus 1. Here minus 2 plus 1 will give you minus 1, and the same thing. Okay, now for here also you can break it in x power 2 by 3 plus this thing. Okay, this is what your x plus some constant. Okay, and this is what your x, if you use this, so 2 by 3 means 2 by 3 plus 1, this means 5 by 3. 5 by 3, the same will happen for 5 by 3. This means this will happen. This means 3x power 5 by 3 by 5. If you differentiate, you will get x power 2 by 3 the same thing. Okay, I hope that it is clear. We always add this constant after finding these antiderivatives. Okay, the same thing will happen for this. So for this term you will apply this thing. So 3 by 2 plus 1. Okay, 3 by 2 plus 1 is 5 by 2. Okay, sorry, yes, 5 by 2, and this will be this thing. So your first term will reduce to x power 2 multiply x power 5 by 2 divided by 5 plus 2 can be taken out. This will be ex, just ex, minus, and log x, it will be just log x. Okay, clear? And plus also the sum constant. I hope it is clear to you. Okay, so this is what happening here. I hope the examples are very clear to you. Okay, so we use just what the theorems, we use just what the results, that's it. Okay, I hope that you understood these integrals as inverse process of differentiation. You understood the examples which shows the results, how to use the results, what result says what do we mean by this C, and everything. Okay, also you must know the standard forms for integration. Okay, without that you are not able to quickly or easily evaluate your integration. Okay, clear? So you must know those basics. So that's it for now for this introductory part for this chapter, inverse process of differentiation as integrals. Okay, so thank you all. We will be back with the more theory and with the more examples for this chapter, integrations. Again, thank you.